So as I like to introduce our presenter, Marty Rosenbluth. He's been an industrial engineer for many years. He's been both associated with different manufacturing processes, including metalworking, electronics, assembly, metal finishing, and consulting. MBR Consulting has been managing business resources since 1987. Marty, welcome.
Thank you, Mike. Thank you. Well, I get asked this question quite frequently, what does an industrial engineer do? A lot of times the answer isn't as simple as I would like it to be, because people don't know. And I guess essentially the best answer is that an industrial engineer deals with people and any processes that people have to deal with. And industrial engineers usually find a better way to make a product faster and easier, a safer way, a less expensive way, and better ways to solve problems by analysis and examination. A better way to make product faster and easier is either to use machines to do what formerly was done by hand, and then also to maybe move things around a little bit in the factory so they're a little more efficient and working next to each other and better flowing of products. A safer way is everything is in such a way that people can't get hurt. We try to do it so it's built into the operation and built into everything that they're doing, but we can't always do that. Sometimes people like to do unsafe practices, which we'll find out a little later on. So a less expensive way, which is always what we're looking for, to keep those costs down, whether it's labor costs, material costs, machine costs, anything within the factory, energy costs, everything that we can think of in a factory to keep those costs down. Better ways to solve the problem by analysis and examination is checking all kinds of reports, see where bottlenecks are at, and then take a look at those bottlenecks and determine what has to be done to free that up so that you have a complete flow of product going through nicely and smoothly. Industrial engineers utilize people, machines, materials, information, and energy. People are the lifeblood of anything that goes on in the factory. Everything that you're doing is related to people. All the operators, all the machines, somebody has to operate, whether it's a CNC machine or it's a manual machine, somebody has to be there to do something with it to make it work. All the different machines, try to use machines to utilize whatever products has to be made to make it faster and smoother and easier, and also less dangerous, because machines can do it better and more consistently than humans usually can. The materials, what materials are we using to build whatever our product is? Materials can change. Sometimes the materials can change to different materials from what was specified originally, because we find out that the original isn't doing what we want it to do, or it's a little too expensive. Vendors are charging us too much, so we want to come in with something a little bit less expensive and keep the cost down, but still maintain the integrity of the product. Information, we're looking for whatever information we can get from the factory floor and tell us how everybody is doing, what we're doing towards expectations. Is the product being delivered at a timely basis? Is it going from station to station on a timely basis? And what about our customers? Are we delivering to them on a timely basis? The energy, we want to keep the energy in the factory, whether it's electric or gas, to an absolute minimum. If we are looking for a new place to build, we want to make sure that the energy that we need is available to be used in the new factory. Okay. Traditionally, IE tasks include efficiency improvements, time studies, factory layouts, process engineering, cost estimating, production standards, establishing quality control plan, forecasting, production control, and safety. We're always going to talk about safety. Efficiency improvements have to do with each area in a factory, whether or not the products are next to each other, where they're located, so the operator has ease of use at their workstation. The time studies are the building blocks for everything. The amount of time that it takes to develop a product at each workstation, added up with all of them, equals what the total cost of the product would be, so the cost accountants can figure out what kind of pricing we're going to be doing on that particular product, along with the materials. Factory layouts, we're trying to keep it so that the operations are in a sequential mode, going from one operation to the next operation in a short distance. We want to keep everything relatively close to each other. We want to make sure that the material handling is done properly, and we can also have them done on a timely basis. Everything is done on a timely basis. It doesn't do any good to have anything waiting for somebody else to move it to another station when they're waiting for work. The cost estimating is, the process engineering and the cost estimating will go together at the beginning of a project to determine what the sequence of events should be on the new product, and therefore what tooling is necessary, what workstations are necessary, what machines are necessary, what people are necessary, and then therefore the manpower. Cost estimating ties in with all of that, and we can figure out, or at least estimate, what the cost of a product would be based on what we come up with in our process engineering. We want to follow that through once we're into production and maybe see how close we were, and just make sure that we're not deviating too much, and if we are, why. So that's just a benchmark that we can use as the product is going through the factory. The production standards would tell everybody what is necessary, what we expect from everybody at a finished product at each workstation, and how long it should take at each workstation. The established quality control plan, we want to make sure that along the way, everything is, all the quality control stops along the way are followed through, adhered to, and that they're pertinent and necessary for whatever we're looking at and doing. As we go through all of this on the quality control, we can then add in our Six Sigma and make sure that we are keeping our mistakes down to a minimum. We want to get to that 0.004 mistake percentage. Forecasting, we try to figure out what we're going to be selling, how much we're going to be selling, and what the product mix will be, and therefore we can also tie into what our manpower should be, what machine we need, and then also comes into play if our layout is correct, and any other manufacturing operations are tied into that. Production control, make sure that we have enough material on hand to do the job, what it's supposed to be done, and that we can ship to our customers at the time that they want the product being delivered to them. So we have to end therefore, all the machines are working, all the operators are on hand, the sequence of events can be had. If we have a machine down, we have an alternate machine that we can go to and just make sure that the product gets to our customer when they need it. Safety. We can build in all the safety that we want, machine guarding. We can put in one way or the other, whether it's a laser to break the circuit, stop the machine from working, a drop-down glass or plexiglass, pullbacks, whatever. We can have all kinds of safety on there, but they have to be used. So it's up to management to make sure that every operator at every station where safety is a requirement, they're being utilized. Safety glasses are used where they're supposed to be used. Face shields, if they need it, are being used. Hearing protection, if necessary. Anything that has to be done safety-wise. The task of workplace layout, we want to make sure that all supplies, and supplies could be raw materials, nuts and bolts, any kind of fasteners, are located where they're supposed to be. We want to make sure that if we're doing a two-handed operation, which is an efficient way of doing it, we want to make sure that the products that are supposed to be done with the right hand are on the right side, and those by the left hand are on the left side, and that the operator can put together parts together without having to cross over, and keeping distance to reach everything at an absolute minimum. Timely refills. Somebody has to make sure that all the parts are refilled in any bins that they might have, whether it's fasteners, actual raw material, what have you, on a timely basis. We don't want any operator standing around waiting for parts. That's the bottleneck that we want to look for in the manufacturer and make sure that doesn't occur. So that has to do with material handlers have to do their job on a timely basis. Timely is a very good benchmark for everything that we do. We want everything on time when it's expected. Timely removal, that means that when the part is finished at whatever the workstation is and becomes work in process, it's either moved to the next workstation, which would be ideal, or into a work in process inventory if we're not ready to go to the next station, which we shouldn't be, but we should be doing everything all the way straight through. Ergonomics, we want to make sure the operators aren't injuring themselves in any way, shape, or form. We don't want any carpal tunnel syndrome. We don't want anybody doing anything that's going to be uncomfortable, take longer breaks than they're supposed to take because they're in pain or something like that. So everything is ergonomically done as best as possibly can be done in today's market. The proper tools, I want to make sure that if they're hammering something in, they actually have a hammer, not the end of a screwdriver. So anything that they're doing, if they can have something, an air driver, if they can have a pneumatic something or other, use that as opposed to a hand tool. Anything that's going to be done faster and easier and makes it easier for the operator and less stressful and therefore less painful for them. If anybody has any questions, just jump right in and ask.
Where do you typically find the biggest opportunities in those categories?
Actually, material handling is a big thing most people overlook. Everybody likes to pay attention to the operation, but everybody seems to forget material handling. And we've got to get the material handlers doing their job and doing it properly, and also using the proper equipment to get the material to the operator so they know that they are doing the right job.
So what type of return, if you got the material handlers working correctly, as you put it, what type of percentage increase do you normally see of improvement?
What you'll normally get, the question is, what type of an increase do you get using material handlers and doing material handlers properly? You will find that the operators that were standing around waiting cease to exist. Everybody is going to be doing their job continuously and with a good skill and good effort, which is always necessary for factory operation. They'll have the parts available. They'll have the finished product removed and free up the space for the next group of finished products that you're coming up with.
Do you find a lot of resistance to implementing changes?
No, most of the resistance to changes comes from management, not from the operators. They're very flexible, and they'll do whatever is asked of them to do. And I think most people don't realize that the people on the factory floor want to do a good job. They want to get it done right, but they want management also to take an interest in what they're doing and get it done right. Some of the tasks are time studies. That's the basis for everything. You need to know how long it takes to do an operation. There are a number of ways to figure that out. You can use a stopwatch, which is the old-fashioned way, but still does the job and gets everything done properly, or a predetermined time, which means that you use something similar to or the same as MTM, and there's some others out there too. It measures every finger squiggle that you use, every reach, gives you a chance to analyze what it is that the operation entails. And then
what's MTM?
Motion time, methods time management. You haven't used MTM in about 20 years.
Oh, all right.
But that is a way that you can use it. The differences are stopwatch If the dollars don't matter all that much, you can use a stopwatch because they generally tend to be a little bit more time involved than an MTM or any kind of predetermined time would be. If dollars matter significantly, then a predetermined time system generally is called for. If it's very capital intensive, stopwatch, very labor intensive, predetermined time. If we're paying incentive on a job, that means that you're paying the operator dollars per piece that they produce, or a percentage of their hourly rate for what they're producing. It could go either way with a stopwatch or a predetermined time. Generally speaking, a lot of union contracts allow for a specific percentage that the operator can come up with, so you have to come up with that value. Stopwatches would allow that closer to it, and it doesn't usually cost the company more to do it that way. Predetermined times, again, come back in when the dollars are extremely important. It's more labor intensive than capital intensive. Non-incentive is like a day work operation. All you're really using it for is a measurement of manpower, how long it takes to do a job, and how many people you're going to need. And it's more of an estimate. It's not always adhered to, but that's management's responsibility to make sure that it is at least close to what it's supposed to be. Line balancing is if you have an operation that goes from one to another to another to another, 6, 7, 8 stations, whatever it is, you'd like to have the time difference between each station between 3 and 5%. Obviously, the optimum would be that each one is identical, but it's not always possible to do that. So you want them to be as close as possible, 3 to 5% difference between them. So there is no bottlenecks in the line, so the product goes from one end to the other end with nobody having to wait for anything. Sometimes when I've been called in, the first station is 5 minutes, the second station is a minute, so they're waiting 4 minutes for a part to come through to the second station. So you don't want that kind of situation to happen, because everybody down the line is just sitting there waiting or helping out at the first station. Not a good situation. Establishing cost, the time value helps to establish the cost because you know how many minutes it takes to do a job, and you can base that on the hourly rate, either from the contractor or what the operation or the operator will be being paid to do a job.
Morris, could you talk a little more about predetermined time and what you mean by that?
Predetermined
and why it would be used in the more labor-intensive or cost-mattering situation?
Okay. The question is, what about the predetermined time? A little bit more about it and why it would be used on a more labor-intensive operation. Because predetermined time has a time value for every single finger movement, hand movement, arm movement, body movement that an operator can make. And it's broken down into specific elements. So if I'm reaching to something, that's one thing. I want to grab a hold of it, that's one thing. And I want to bring it back, that's another value. The time values have already been determined as to what they would be. So I would add all those times up, and that would be the predetermined time for that particular operation. There are some rules and regulations that you have to follow, whether or not the weight of the product is, whether it's a dangerous product or not a dangerous product, and that helps you too when you're methodizing an operation, because then you can see if I'm reaching 12 inches to something, why isn't it 6 inches away? So that helps you to see that kind of thing to methodize an operation. You'd use that because in industrial engineering parlance, the standard time that you come up with is tighter than a stopwatch would be. By that I mean a stopwatch takes into effect any movement that an operator can make, whether it's extraneous or necessary. And then the predetermined time says it's going to take this much time to do it, and that's it. So on the stopwatch, so we get back to that, we do what we call judgment leveling. So if I see an operator that is doing an operation and I will see some extraneous movements going on, I can factor those out of there and bring it down closer to the predetermined time, but generally speaking, it's still going to be a little bit looser than a predetermined time would be. the factory layout, I want to make sure that all the operations, whether they're machines, operator operations, or whatever they are, they're sequential. We want to go from one to the other, and we want to make sure that there's nothing in between. We don't want to go from here to here, back to here. It's just too much time involved to do that, and it's very inefficient to do that. The material handling, get back to our material handling, want to make sure that the material handlers are watching their particular operations and keeping the operators filled with parts, filled with raw material, and anything else that they might need to get their operation done without them having to stand around and wait. We'd like to have the raw material stationed someplace relatively close to where the operations would be, so they don't have to go from here, back to here again, filling up an operator with raw material. Same thing when we're finished with the product, we don't want to have to go from here to here, back to here again when we're going to ship something out the door. So we want to have everything in a sequential fashion within the building so it can be done smoothly and easily. The outgoing finished products, we want to make sure that the staging areas are near the trucks or wherever they're going to be. We try to keep the finished goods material inventories down to a minimum. We don't want to keep, that's a lot of dollars sitting on the shelving, doing nothing, collecting dust. Some consumer products will do that kind of thing. They'll have raw material, but if we're doing something between two factories, going from one factory to another factory, we're supplying them. We want to try and keep it so we're going just in time. We'll go right from the finish line to the truck. Yes.
Have you got any case studies or examples of what you're talking about, companies that didn't do it right and what happened to them?
The question is if I had any case studies of any companies that didn't do it that way and what happened to them. Generally speaking, if they don't do that, and they put things, finished goods on a shelf somewhere in the back of the factory, I have found that a number of those places, the products have become obsolete, and they now have to turn around and sell those products at a reduced cost just to get them out of their factory. And they don't make any money. So that's been sitting there, all the dollars have been sitting there on the shelf doing nothing, collecting dust, and then they have to turn around and sell it because it's now obsolete. Those that put it go from the packing line to the truck end up having the best operation. Number one, it's a smaller factory. You don't need the shelving for the finished goods, so you have less square footage on the floor. And then proper spacing. There's one thing we want to do when we're laying it. I hope that answers your question. When we're doing a factory layout, we'd like to make sure that the spacing on the floor is adequate. We want to make sure that we can move between operations easily and smoothly. We don't want somebody being in the way. We don't want things in the middle of the floor to slow down our forklift operators or whatever else we're using for material handling. So everything, the old industrial engineering saying, is a place for everything and everything in its place. We like to keep it that way. Okay. Safety. We want to keep the machines guarded. Whatever the machine is, we want to make sure that we have some kind of guarding on there so operators will not get hurt. If it's a punch press, we want to make sure that their hands cannot enter the punch area when the machine is being activated. Range from the old way of just having pullbacks on the hand to go back when the machine is pressing, or we have a plexiglass shield that can come down and block the entryway for the punch press, or maybe a laser beam if your hand breaks that beam, the machine is inoperable. So it can't be done. Whatever it is and whatever it takes to guard the machine, we should have that in place. I've seen too many fingers disappear in punch press operations. Forklift training, very essential. We can't have just somebody driving a forklift. They need to know exactly how to drive that forklift within the factory We don't want to skewer anybody with the forks on there. Yes.
I was at a plant where the forklift driver actually ran over himself. Seriously, he actually ran over himself, and it wasn't me. But
Did he ruin the forklift?
actually, he did a bit of damage to it. He got hurt. I think they burnt out a motor on the forklift.
Now you know why it's necessary to have proper training on how to use the forklift. Also, if the forks are going up, you want to make sure that the weight on there is such that the forklift isn't going to tip over because it's now out of balance. The center of gravity hasn't shifted in such a way that the forklift truck falls over. Safety equipment. We have other safety equipment that we will need throughout the factory. Depending if you're handling hot steel, you want to have the proper gloves on, maybe a face shield to keep from getting hot sparks flying into you if you're running a forging operation.
Ouch.
Ouch, yes. If the steel is heated up to 2,300 degrees, you want to make sure that the steel that's coming at you you're protected from it. You want to have the proper tools for the job. If you're you're screwing something in, you don't want to have a hand screw because number one, you're going to end up with your carpal tunnel on there. So you want to have pneumatic screwdrivers, any other tools that you need. Make sure that they're the proper ones. You don't want anybody getting hurt, and you also don't want to break the tools and have something go flying. People have been using screwdriver handles for hammers for I don't know how long, and plastic goes flying in all directions later on after it's been used for quite a while. So if you're going to do any hammering, get a hammer.
I'd rather have a screwdriver to get hammered, though.
The hammer's not going to fly off. I'd rather get a hammer. The screwdriver isn't going to fly.
I got it too.
The insurance studies show that it pays to be safe. You're going to save about $3 for every dollar that you invest in prevention. And that's going to come because you don't have workers who don't come in because they're hurt. You don't have claims that you have to pay, and it comes back in the form of lower premium. So it pays to be safe and use the safe tools, equipment, get the training and the guarding. Okay. One other thing, when you're doing the safety, we can put all this safety in place, have all of the up-to-date safety equipment. Everything is nice and up to date, and you have some operator who decides that it doesn't apply to me. I can do whatever I want to do, and I can do an unsafe operation. So I'm going to show you a couple of things here. Signs like this, while they're good now, become invisible after a while. You don't see them. So you need to keep reminding everybody that safe practices are the mode of the day. I don't know. Mr. Unsafe, yes.
We used cattle prods to make sure compliance came through.
There you go.
Easier. You know where I've been some of the places, so that makes sense to you.
The comment is that we use cattle prods to make sure everybody is safe. Now, this is how signs. Nobody pays attention. Do not climb, play on, or in a round pipe. Everybody saw that sign when they went onto this pipe with the crowd out here. So signs become invisible after a while. You just don't see them anymore.
Like I said, you used to have one of those kids with a cattle prod, all the rest of
them would be like a bunch of dominoes.
He got that much.
They won't have to worry about it any longer. Another unsafe practice in the factory, standing on the top of a rounded trash container to hang a sign.
That's the safety sign.
That was the safety sign. All right, now, before you do anything with this one, this personifies everything that we talked about in unsafe practices in a factory. We'll see a forklift driver. We're going to see, I don't know if you can see it just yet, forklift driver, we're going to see a plant layout that doesn't work. We're going to see things that aren't where they're supposed to be, and click on it. No, you want?
Sorry. It's going, yes.
Put the mouse on there. And click on it. Just click on the picture. Is that doing it?
It's set up as a left.
Yeah.
Darn.
Oh, I will have to get this one operating
Video?
overall through it, this whole thing, so you can see this in action over here. It is very memorable, and you will enjoy it. And you will also know what not to do.
Do you think if I go out a slideshow, we can do it maybe?
No. We'll get to it. Okay. And what does an industrial engineer do? An industrial engineer will be involved in every facet of manufacturing and operation. Anything and everything that has to do with manufacturing will include an industrial engineer. Industrial engineer may be involved in other facets of manufacturing operations. Cost accounting, certainly we end up putting the cost together, whether it's the prime cost, whether it's labor or whether it's material or both, and how much a product costs. Purchasing, work with the purchasing department to be able to bring in the proper material, equipment, packing materials, fasteners, anything that might be necessary to get the product out. HR have gone and handled grievances with the union and the operators, and also have end up doing other HR work within the factory. Job descriptions. Contract negotiation. Can sit in on contract negotiations and help and determine some of the language within the contract. Project management. Any kind of projects that a factory has and has to get done, needs somebody to go ahead and do it, and that's be an industrial engineer, because they would have to handle, if it has to do with IT, it has to do with operations, and maybe it has to do with the production. We have the industrial engineers being the liaison for that, and anything else. We do anything else that management deems has to be done in a factory, falls upon the industrial engineer to do it.
Standing on rounded trash cans.
Standing on the trash cans and with the net.
We can see that.
Somebody has to do that. So, any questions, comments, discussions? And I've got to go back and I'll show you that.
How are you involved with HR?
I have done, personally, I have handled union grievances. I have gone in there and done some job descriptions, done payroll, created payroll as a project, actually. It was a payroll project. So yeah, I get involved. Reporting, any kind of reports that may be necessary for the factory to get the product out the door. Whether it's production reports, dollar reports, how much they're making, if they're on incentive, if they are over incentive, under incentive. If everybody is over incentive, they're making well over 100%, the cost of the product remains the same. If they go under 100%, then the cost of the product goes up. So I have to watch and make sure that everybody stays over 100% on an incentive factory. So we keep the costs what the standard cost should be. Yes?
So what's the most interesting industry that you've been involved in?
Other than the trip to the Southern Illinois with you.
Which trip?
Pig farm.
Oh, my.
Yes.
Wasn't a farm.
No, that wasn't a farm. I had a project myself one time. Panasonic, naming names, called me in to go to Motorola because they had sold them some equipment and Motorola was not using the equipment properly. And they wanted me to report back what was going on with it. That was kind of fascinating to go in there, listening to them on the one side, complaining and seeing that what they're doing wrong, and then having to report back to the other one. I had another project that took 2 years in the making. It's on an airplane every week, every Monday and Friday for 2 years, a payroll project. We automated the payroll using barcodes. And so we had to set up their mainframe computer, which was an AS400, had to get that working properly, had to program the scanners that everybody used. Every operator had a handheld scanner, and we had to tie it in with the PC. I wanted to go live with it. They didn't. They wanted to download it, and they ultimately went out. But then they were sorry they did. They should have put them on.
So, what was your most sleep-inducing client?
The sleep-inducing one, unfortunately, is anyone that has to do with time study. You're watching
Which industry?
any industry. If you're watching somebody work,
He
it
sets it up
sounds
for the
good.
mattresses.
It sounds good. I know. It sounds good. However, that wasn't the most sleep-inducing.
But it was the most comfortable.
It was the most comfortable, yes.
Marty, what trends have you seen over the last 23 years? From 87 till now? Supposed to be 1887.
1787, right after the Constitution.
Okay, 120 years.
Since the beginning of the Industrial Revolution.
Electricity for what?
You look real good for it.
Thank you. I was born February 29th, so I only have a birthday every 4 years.
What do you think is the biggest trend since the Industrial Revolution? I think that's what your question was.
No, the question in industrial engineering, what have you, my own experience has been, lean has come along.
Yes.
Those things have come along.
Yes.
The cell phones, the whole concept of Six Sigma.
All the other Japanese terms, the Six Sigma, the Kaizen.
I didn't mention many of those.
I know, I didn't get into that. And then with the PDAs using that, that becomes a better stopwatch using the PDA than using the old stopwatch. So, a lot of innovations within the shop itself, machining, machines that do multiple operations, not just one. Yes.
I love the quiver of fear and
What do you think the effect of social media will have on industrial engineering? How will social media in itself and the rapid transactions or communications that happen, how will that affect industrial engineering?
I don't know if it will have a direct bearing on industrial engineering as such. However, it probably will help individuals who have specific situations that maybe they've never encountered before, or some other situations that some other people have, and just an exchange of ideas and an exchange of answers for questions. I don't know that it would have any specific. You have another.
Do you have a differing opinion?
Me? No. I got no opinion. So how does an industrial engineer go and build his business? Who do you normally look to find?
I look to find, for myself, a small company that has no industrial engineer on staff. They generally like to utilize floor personnel to do something that would be industrial engineering related, such as a factory layout, such as trying to determine times at each operation, just anything of that nature. Because those people usually can't do the job properly. They need somebody to come in who has done this before.
back to the time study. I used to work at a production machine shop, and we had machines that would cycle and could keep running if you kept them fed with parts. So I think that in that case, the stopwatch is a better indicator of cycle time and everything. I think and then the other one would be more if you were just working on something individually and not having a machine run during that time.
On the ones with the machines, if somebody is watching more than one machine, they have what they call a multiple machine complement, and you want to know how many machines can one person handle before a machine is sitting idle and just waiting for him. So you want to try and get to the point where you're going in your circle and machines are idle for an absolute minimum amount of time.
Yeah.
If they have to be because you have a load and unload. So you want to keep it down to an absolute minimum. And there are a mathematical formula that you can use to calculate that.
Yeah, we had a work cell where we had 2 people running 3 machines, and we were able to keep up with that. It's kind of interesting.
Well, generally speaking, you probably have 1 person running the 3 machines if you could do that, and do it properly. The machine does what it's supposed to do, and you keep that load and unload time just to that load and unload.
Along the lines of what Fred was asking about social media and actually, today I had an email that asked me what smartphone I use from one of the lean consultancies. And the implication was that they were looking to create some widgets and apps for smartphones and whatever type thing to be right at your beck and call, like you just like Marty pulled it up.
Well, there are companies out there who already have time study apps that you can put on your PDA. There's a couple of them that advertise in Industrial Engineering Magazine. So, yeah, and I've had one previously when I had a pump. So, yeah, there are apps out there to do just that. I want to create my own. I see a hand going up.
So you mentioned the steel industry earlier.
Yes.
And you have experience in dealing with were they local steel manufacturers? Were they overseas? Were they, and what did you do?
One of the local companies that I dealt with in steel was a forging operation. They did the forging here. I don't want to say it was overseas. It was in Kansas. So we imported the products from Kansas. And the forging, machining, and everything else was done here in Chicago. The finishing, heat treating, even in some cases, plasticizing the handles, and we're all done here in Chicago.
Are they still around?
Yes.
I'd like to talk to them if I could.
I haven't seen them in a long time,
Okay.
but we can talk.
All right.
And would you get involved as you're working on one of these projects? Would you then, like, using the steel, you said the forging was done locally, the machining was done locally, and this was all by one company that was doing this. And if you found out, or if you got in there and you got involved, one of the things that you would be doing would be perhaps recommending outsourcing some of the processes because you were finding that it would be more cost effective or expedient for them to do so.
I haven't found too much outsourcing that would be cost effective. A lot of times, if you can't make your own product and you have no business being in that business, you want to be able, sometimes you do have to import from Kansas regular parts that you might need. This particular company did have some zinc parts that they weren't capable of producing themselves, but they bought them locally, and they were just bought as a completed product, and then they just did whatever they had to do to finish up on there. They would not, generally speaking, they did not outsource. If they did, which will be the exception, not the rule, is because the demand was higher than they were capable of handling in their particular facility, but it would still be outsourced to a local company.
So given the comment you made about outsourcing and making your own product,
Yes.
why do you think so much of it's going on?
I think a lot of that is people are doing that without thinking about it. They're just following somebody else's lead because they think if they're doing it, we got to do it. I was talking earlier, and I think that if something is capital intensive, I don't think it's really worthwhile doing it offshore. And labor intensive, the only thing that I can see that might be outsourced, and I don't like it, but it's there, and that's call centers, because it's all labor. But anything that's capital intensive, I can't see how you're saving money by doing it offshore. I know of some companies that ship raw material across the seas to get it done, and then they have to pay to come back again. I had inquired about a year or so ago what the cost of a container was for somebody who's in the logistics industry, and they told me a 40-footer could be about $3,500. So that's twice that you're doing $3,500. Whether it's full or not is another question. And then also the shipping lines last year cut back by 20%, which means it has 20% less containers that you have. So unless your name is Walmart, you're probably not getting a good deal on shipping any longer.
Have you gotten involved in any studies of bring something back?
No, I haven't, but I wish I would.
Yeah.
I would like to.
Yeah.
I would like to
Let's
see
do
what that
that.
does.
Let's go get him, Marty.
I'd like to show you that one video that we did before. Go back out to the Windows Explorer and go to my. Right click on it. Yeah. Double click.
There we go.
It's just connected.
You got it?
Oh,
gosh.
Oh, man. Ouch.
Elsa.
Baby.
At least they got it on video.
It was a security camera too.
It would have been, but it's wasted.
Wow.
Click on it. Before you go, watch.
Was he
As
employed?
he's going in through here, you'll see him jump out of the cab of the forklift, fall down, get up, start running. As far as I know, he's still running.
That's the worst thing to do.
The tax case.
There's a cage at the top of it, right?
Right there.
There he goes.
There we go.
One leg of the shelving unit.
It shouldn't collapse like that. I've hit him on forklifts that knocked the bolts out. They didn't fall out.
Loosely made section shell.
That's bad.
So this violated every safety rule that we can possibly think of. The aisle was too narrow. There was product sticking out into the aisle that shouldn't have been. The forklift operator should never have even tried to go through there. And I don't know if you noticed it, but as he went through, his loads shifted on there because he was trying to go through sideways and just barely made it and put a stanchion on
The
the
load wasn't too balanced either.
Yeah, and he kept on going, and that's what pushed the stanchion out of the way.
That's smart to run.
You're
safer on the forklift.
Well, you get the cage.
Yeah.
Yeah, he's safer there until management comes out.
That's why he was running. Now it's not safe. You don't know the plant man door was right in the direction he was headed, okay?
See, here comes the
He was late for lunch. Oh my gosh, that's amazing. Yeah, I had something fall from a couple stories high onto a forklift, but you just watch it, just comes down, hits the top,
Yeah.
and you're safe. But,
Yeah, well, this one. So whatever was on there on those shelves, I don't know what was on there. I can guess, but I'm not sure.
any other
Total loss.
What else do you have for us, Marty?
more video.
No, unfortunately, that's the only video I have.
It's the only video you can show them.
That's right.
Well, that's it. Yeah, especially if we're going to be streaming live. Any other questions, comments? Jim, I'm sorry.
I'm sorry.
Thank you
Well,
very
thank
much.
you.